I think everybody knows the answer to problem number 1. 2 to the x equals 8, so x must equal 3. Easy. Now the next one. This one has an additional complication. Step 1. What do you think? Divide by 3. So when we divide both sides by 3, we'll be left with 4 to the x, because those are going to cancel. We'll be left with 4 to the x equals 16. 4 to what power is 16? 2. So step 1 has to be that division. All right, let's look at the next one. Uh-oh. Uh-oh, we got a problem here. 8 is not a power of 4, like 4 squared or something like that. It's not. However, 4 and 8 do have something in common. They are both powers of 2. So instead of 4, I'm going to think of that as 2 squared. I'm going to think of 4 as 2 squared. And instead of 8, I'm going to think of that as 2 cubed. 8 is not a power of 4, but 8 and 4 are both powers of 2. So I will rewrite 4 as 2 squared and 8 as 2 cubed. So now I have 2 to the 2x equal to 2 to the third. Well, wait a minute. If 2 to the 2x equals 2 to the third, what does that mean? 2x has to equal 3? Doesn't that make sense that these two would have to equal each other? So x equals 3/2. Now, the first two problems were easy because 8 was a power of 2 and 16 was a power of 4. If you don't have numbers that are powers of each other, you want to try to make them powers of the same number. We call this getting a common base. 2 squared is 4, 2 to the third is 8. Let's look at the next. Maya, was your hand up, sweetie? Okay, let's look at the next one. Very hard looking problem. Divide by 3. So 4 to the 2x equals 32. Now, is 32 a power of 4? In other words, no. 4 squared. 4 squared is 16, and 4 cubed is 64. You don't take 4 to a power and get 32. So we're going to have to do what we did over here. Can we rewrite 4 as a power of 2? 2 squared. What about 32? Can we write 32 as a power of 2? Yes, thank you, Jordan. 2 to the 5th. Now, what does this say? 2 to the what? 4x. Now, what do I do at this point? If 2 to the 4x equals 2 to the 5th, 4x equals 5, and x equals 5/4. What? And let's try a couple more, we'll get it, don't panic. 2 times 5 to the x over 3 equals 250. You guys look really smart when you do these problems. This looks hard.
You'll be feeling smart.
Step 1.
Okay, you divide by 2.
Divide by 2. So 5 to the x over 3 equals
5 x over 3,
125.
125. And then, don't you have to multiply by that little 3?
No, that's an exponent, so we just want to leave that. But 125 is a special number.
Oh, that's 5.
It's
to
5
5
cubed.
5 cubed.
So we have to be able to recognize, kids, that 125 is special. It's 5 cubed. So we have 5 to the x over 3 equals 5 to the third. What does that mean? If 5 to this power equals 5 to this power, then they're equal. Which means x will equal 9.
Okay, I got you now.
See, if we just do enough of them, we'll get the hang of it. All right, here we go. Next one. Step 1. Maya, you are right. So 9 to the x plus 3 will equal 27. That's 54 divided by 2. Now, we're going to write the 9 and the 27, we're going to write them both as powers of 3. What's 9? 3 squared. And 27 is 3 to the third. Now, what exponent am I going to have here? 3 to the what?
2x plus 6.
2x plus 6 equals 3 to the third. Now this is the cool step. If 3 to this power equals 3 to this power, then they're equal. So 2x plus 6 equals 3.
You subtract 6 over, you get negative 3 equal to 2x.
2x equals negative 3 and x equals negative 3 halves. We subtract 6 and divide by 2. Now G might be freaking you out because it's got fractions in it. But let's relax. Step 1, divide by 36. Now, what happens when I divide 9 by 36? What do I get? I get 1/4. I'm going to leave that as a fraction because 1/4 is something special. What is 1/4?
It can be changed to 1.
That's
Pardon this interruption, Mrs. Ford.
Yeah,
Is Tim Kelly present in your class at this time?
he is.
Thank you.
they didn't say
Well, I
that
didn't
though.
say they want you. They don't want you, Tim. We just want to make sure you were here. Apparently you skipped first period.
They need have done that before. Is he here? Yeah, just checking. Just checking.
Okay, so 1/4 is indeed Maya McLaurin 4 to the negative first, but it's also 1/2 squared. 1/4 is 1/2 times 1/2. So I'm going to rewrite that 1/4 as 1/2 squared. Kids, I don't know if you're getting the hang of this or not, but every single one of these problems I've done, my goal has been to make these match. I wanted to get like 3s on both sides or 5s on both sides. Here I want to get 1/2s on both sides. Why do I want to do that?
Because then they'll be equal.
That's right, so I can drop them out and just say x over 4 equals 2. Which means x equals 8. I can't do that with my exponents unless these two numbers match. If these don't match, I can't do anything. So I want to make them match.
Okay, Javon got this. Divide by 27. I don't know what that is.
I don't either. I need to work that out.
It's
It's
not.
9. Somebody with a calculator.
1/3 x equals 9.
Now, stop. What do I need to have happen? I need to have these numbers match, right? Now, this is a 1 over. So I could rewrite, I can go either way. I can leave this as a 1/3 and recognize, okay, if I need to change this, it's gonna have to be a negative exponent, right? And since it's a 9, that's 3 squared. So this would have to be 3 to the negative second. And 3 to the negative second means, oh no, never mind. No, that's gonna be too tricky. That was wrong. That would actually be 1/3 to the negative second.
I was about to
Yeah.
Yeah, that's a little tricky. Let's do it this way.
Wait, did you do it negative?
This guy, yeah, what, it's gonna be negative. Then let's think of this as 3 to the negative first power. Is 1/3 3 to the negative first power? 1 over, right? What's 9? 3 to the second. I think this is an easier way to do it. So we'll just change this into a 3, and we'll change this into a 3. We'll change them both into 3s. So this would be 3 to the negative x. This is 3 squared. So negative x equals 2, and the answer to the question is negative 2. Now you're going to get that no matter what if you do it correctly, but I think it's easier here just to change them both into 3s. Okay, one more of these, and that's all that's left.
Do we still get hugs on Fridays?
Why would we not?
I was gonna say, can we bump it up like a Tuesday?
Okay, here we go. Here we go. Step 1. Divide by 1/8, which is the same as multiplying by 8. So I'm going to multiply both sides by 8. So 2 to the x over 5 equals 64. Is 64 a power of 2?
Yeah.
Do you know which power of 2?
6.
Very good. For those of you that don't have that memorized, you can figure it out, right? 2 times 2 times 2 times 2 times 2 times 2. So what's the next step then? X over 5 equals 6, which means x must equal 30.
30 balls. 30 balls.
Okay, now I'm going to make one up, and over to the side somewhere, if you've got some room, I want you to see if you can do this, okay? Here we go. here's our practice problem to see if we're actually getting this. Pardon? 18. There's some holes in the Stop. Those are holes. It's 18. So 2 times 27 to the x equals 18. See if you can figure this out. No talking. See if you can just figure it out. Yeah, that's an 18. There's just some holes in the blackboard for some reason. Bryce, you got an answer already? Good for you. How'd you start it, Bryce?
Divided by 2.
Very good. We're going to start by dividing by 2. So 27 to the x equals 9. Now, everybody in the room knows, because we've done a whole bunch of examples, that we need these two numbers to match, right? 27 and 9 are not random numbers. They are both powers of 3. So we'll change the 27 into 3 to the what? Third.
Oh my gosh, I almost had
And we'll change the 9 into, so now we have 3 to the 3x equals 3 squared. And now we can build a little equation that says 3x equals 2. So what did you get as your answer? 2/3? How many got 2/3 all by yourselves? Oh, you are amazing human beings.
I'm so excited, oh my god.
Okay,
Thanks, dude.
now we're going to the next part, which looks different, but it's really the same thing. Let's look at this next problem. Are you paying attention? Table 1 here, Chatty Cathy girls. Are you paying attention? That would be you guys.
I like to call them talkative thumb.
What are we eating?
Is it log 7 to the 7?
How do we do this problem?
7 to the x.
7 to the x equals 49. Does that look similar to the ones we've been doing? Well, yeah, it does. This is an easy one. 7 to what power is 49? 7 to the x equals 7 squared, so x equals 2. X is 2, 7 squared. So that's easy. Let's look at the next one.
8.
You've already done it because you're geniuses. Kids, I am ancient. I have done math for forever. My brain cannot digest this. When my eyeballs see this, my brain immediately thinks this. That's how you have to be. You have to look at this and think 2 to the 3rd equals x. Because then you know what the answer is. The answer is 8. If I don't do that, I don't know what the answer is. I have to translate it. And you do too. 2 to the 3rd equals x. Next. Little bit harder equation. Come on now, hang with me. We're going to do a few more. Do a few more and then we'll stop.
No, we don't stop.
Taylor made it.
Well, we've got something else to do. But we'll stop with this. Okay, this is a tougher equation, but we're going to do it exactly the same way. Veronica, any ideas how we might handle that problem? Okay, we're going to handle it exactly like we handled this one. So what did I do with this one? 2 to the 3rd equals x. So what am I going to do with this one? Yep. 4 to the 2nd equals x plus 2. That's exactly right. 4 to the second equals x plus 2. 4 to the second is 16. So the answer to the question is? Hey. No, I mean it. We really do. This is big stuff. Okay, problem D. How are we going to start problem D, Maya?
3 squared
Yep. Equals?
1 minus x.
Yes, Maya, you are exactly right. 3 squared is 9. Now don't be confused by this, just do it one step at a time, subtract 1. So 8 equals negative x, and x equals negative 8. That's exactly right. Now, E introduces a little bit of an issue. There's that number out in front, isn't there? Any idea what we might do with that number out in front?
You,
We got 2 choices. We have 2 choices with it. Okay, one choice, Abby says, is that could be an exponent. And she is exactly right. Shh. Because, we have talked about this before, a coefficient in front of a logarithm is really just an exponent. However, you could handle this another way too. That's one way, it's perfectly fine, but there's something else we could do that might make it even easier. What if we just divided both sides by 2? Is that legit? Can I do that? Absolutely. Mrs. Ford doesn't do not right things. We always can trust Mrs. Ford to divide correctly. We're going to divide both sides by 2, and then what? Veronica, this is back to your problem now. What would this be?
4 to the second.
Exactly. 4 to the second equals x plus 1.
Okay.
So the answer to the problem is 15. Now, Abby, this is one of those perfect situations where there's more than one way to handle the problem, but one way is a lot easier than the other way. We could make that an exponent, but since we can divide it out, let's just go ahead and do that. Okay? And one more. Patrick Troy, any idea, this one looks a little bit different, any idea how we might handle this? Shh. Did you hear what he said? He is on target. Say it again, Patrick. Subtract the 6 over. Let me catch up. Subtract the 6 over. He does not want to have this extra number hanging around. He's going to move that.
Get rid of that.
Now what, Patrick? Divide it by -3. Perfect.
What you know about that line? Then you know that makes it a positive.
And then, Patrick? You are exactly right. We're going to translate that into its exponent form.
36
squared equals 4 plus x. So it looks like the answer to the question is 32. Okay? All right, I'm going to give you something then. We're going to start practicing. We're going to be having a big quiz, like I said, relatively soon.